Okay, we will wrap up chapter 3 today with talking about real zeros. Real in the sense of numbers, real numbers, not imaginary numbers, not complex numbers, but real numbers. They could be decimals, fractions, positives, negatives, whole numbers, you name it. And we're going to talk about how to find real zeros. Now, remember, once again, when you set an equation equal to 0, you're finding the x values that give you a y value of 0 because you want to find out where the equation hits the x-axis. So that's what we're up to. That's what we're trying to do today. This will wrap up chapter 3. Our next session together will be a review session for chapter 3, and then we will have a test on chapter 3. So let's get started. Just as a measure of review, this is finding the zeros of this particular quadratic equation, okay? Now, this is factorable, and I did factor it for the prime reason I wanted to show you something that is kind of fascinating as far as figuring out what could be possible zeros. And that is, when you factor this, you have combinations of the factors of 6 with the factors of 10 that are going to subtract to give you 11. And that's how you get these factors. And we've talked about this many times before. You set each one equal to 0 and you solve, and you get -5 halves or 2/3. But what is really, really interesting here is that the 5 and the 2 are factors of 10, and the 2 and the 3 are factors of 6, which means when you're trying to say to yourself, what numbers would be possible zeros, as long as you put the factors of the last term on the top and factors of this one on the bottom, you can get all possible factors. And that's the way I have it down here. If you're looking for possible zeros, always consider all numbers with the factors of the leading coefficient, 6, on the bottom, and factors of the ending constant term on the top, okay? So let's go on and try an example of that. If you consider x cubed minus 3x plus 2 and find all possible zeros, what are all the various things that could be zeros? Well, what you want to do is put factors of this, 1, okay, we put on the bottom, and you put factors of 2 on the top. And hold on one quick second. I've got a typo there. Okay, sorry about that. Had a typo on the PowerPoint. The factors of 2 would be on the top. The factors of 1 would be on the bottom. So you're going to get plus or minus 2, or 1/1, which is another factor of 2, plus or minus 1. So essentially, there's 4 possible fractions, plus or minus 2, and there are 4 possible zeros, plus or minus 2 and plus or minus 1. And how can you tell whether they're going to be zeros? You can use synthetic division, because if something is a 0, it should give you a remainder of 0, because not only would it be a 0, but it would be a factor. So let's try it. We have x cubed minus 3x plus 2, and we have a missing term, so we have 1, 0, minus 3, and 2. I always tried 1 first, so let's do that. 1 times 1 is 1, 1. 1 times 1 is 1, -2 is 0. And you have found that 1 is a 0, and x minus 1 is a factor, okay? So there you've got a 0 right there, x equals 1, and look what is left. We saw the last time we talked about synthetic division, because you start with a cubic and you divide by an x. This is knocked down to an x squared. So this is x squared plus 1x minus 2 equals 0. That's what you have left. And that you can either use the quadratic formula, or you can factor it. And I think it does factor. X and x, factors of 2 that subtract to give you 1 are 2 and 1. This sign goes with the biggest on the outers, and you're going to end up with x equals 1 or -2. So you end up with 3 zeros. You have 1 used twice, and -2, and go back to what we talked about the last time. If you want to sketch this, you have 1 used twice and -2. It is a cubic. A positive cubic end behavior is up on the right, down on the left, okay? And we know because 1 is used twice, it's going to bounce on the 1. So this curve comes up. We could even find where it hits the y-axis, put 0 in, it's going to hit at 2. So it comes up, it hits at 2, comes down and bounces and goes up again, okay? Beautifully simple and easy, okay? Let's try another one. This one is going to be much more interesting. Oh, we want to find all possible zeros, and then the true zero is x to the 4th. X to the 4th, we know end behavior's up. Well, what happens in the middle? And that's going to be a real fascinating problem. So you put factors of the last term on the top, factors of this on the bottom. So you're going to get factors of 10. Everything's going to be over 1. So your possible zeros are plus or minus 10, plus or minus 5, plus or minus 2, plus or minus 1. Okay? Which means we have 8 possible zeros. And you say, 8? I've got to do 8 synthetic divisions? No. You just know that your zeros are going to be in that group. Okay? So it gives you something to pick from. All right, like I said, I always try 1 first. Get your coefficients, no missing terms. Drop the 1, -4, -4, -9, -9. Yikes. What's that? 14. 1 times 4, that doesn't work. So 1 did not work. How about 5? Let's try 5. 5, 0, 0, -5, u, -25, -2. There it is. So 5 works. Okay, we know that x equal to 5 is a 0 and x minus 5 is a factor because there's no remainder, divided evenly. And look what you have left. You have x to the 4th. Remember, it's always, sorry. You have x to the 3rd, 1 less, plus 0x squared minus 5x minus 2 equal to 0. Okay? What am I going to use now? Factors of this over factors of this, plus or minus 2, plus or minus 1. So let's do synthetic division on 1, 0, -5, -2. Let's try, how about 2? So we have 1, 2, 4. Now, for heaven's sakes, 2, 4 here, -1, -2. 2 did not work. How about we try -2, see if that works. 1, -2, -2, +4, -1, +2. That one works. We have another 0 of -2. X plus 2 is a factor. And we are left with a quadratic equation right here, which is 1x squared minus 2x minus 1. Okay? Can you find factors of 1 that subtract to give you 2? No, you cannot. But you can do the quadratic formula on this. Opposite of b is 2 plus or minus square root of b squared is 4 minus a. Oh, I'm making so many mistakes today. What? Minus 4 times a times c all over twice a. This would be 4 plus 4 is 8. So I have 2 plus root 8 all over 2. So let's check that out. The square root of 8 is 2.83. So I have 2 plus that would be 4.83 divided by 2. I get 2.42. And 2 minus 2.83 is a negative 0.83 divided by 2 is a negative 0.42. There we have it. You've got all 4 zeros, okay? None are used twice, so you know there is no bouncing. Okay, so let's put the zeros down to sketch this. We have at -2, we have a 0. We have at 5, we have a 0. At 2.42, we have a 0. And -0.42, we have a 0. End behavior, we said, was up and up. You can even find where it hits the y-axis by putting x in for 0 everywhere. It's way up here at 10. So we know this curve comes down here, here, down here, and up like that. There is no bouncing whatsoever because none of the zeros are used more than once. That is an amazingly difficult problem to try to do. But with synthetic division, it is not difficult at all. Okay. Try the next one. We have zeros with possible zeros would be factors of 6 over 2. Factors of 6 over 2. Well, you can put factors of 6, which are plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1, over factors of 2. So if I put them all over 1, I just get these. Okay? If I put them all over 2, I'm going to get 3 here. Put this one over 2 would be plus or minus 3 halves. Put this one over 2, I'll get just 1, okay? And put that over 2 is plus or minus 1 half. So there's quite a few. What about 12 possible zeros? I must tell you, back many years ago, when I was where you are, taking a calculus course, my professor was a bit of a sadist. And he would only ever give us equations that had fractions that worked. Oh boy. And it was a lot of work. But this should not be a lot of work. Let's try it. Are there any missing terms? No. 2, 1, -13, and 6. Remember, I just always try 1 first. You don't have to. So this is 2, 3, 3, -10. That doesn't work. How about -1? Try that. -2, 1, -1. Nope, that doesn't work. So 1 doesn't work. Let's try 2. 2, 4, 5, 10, -3, -6. Hot dog. I know that x equal to 2 is 0. X minus 2 is a factor because it comes out even. And now look what you have left. You have 2x squared plus 5x minus 3. That's a quadratic equation. 2x squared plus 5x. I think I said minus 2x squared plus 5x minus 3 equals 0. Can you find combinations of factors that are going to subtract to give you 5? I think we can. So let's try to factor. This would be 2 and 1, 3 and 1. If I pair, the 2 and 3 is 6, so 2 and 3 and the 1 and 1 get flipped and they go in the inners. This sign goes with the biggest, right, like that. 2x squared, positive 5x, factors perfectly. Set each part equal to 0, you're going to get a half, which is right there, and you're going to get -3, which is there. There are your 3 zeros, okay? Once again, end behavior for a cubic is down on the left, up on the right. Is there any bouncing? No, they're all different. So I have zeros at 2, -3, 1/2, down on the left, up on the right. When x is 0, I'm at 6. So I'm up here at 6. So it comes up like this, comes down through like this, back up. There is no bouncing because none of the zeros are used more than once. Okay? And that is how you solve very, very, very complicated problems. Okay? Let's go to this one. Possible zeros would be factors of 18 all over 1. So it's plus or minus 18, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9. Right? Okay, here we go. So we have 1, 4, negative 3, negative 18. Notice there are no missing terms. Okay? I always try 1. That might be stupid, but I always do. 1, 5. 5 didn't work. Okay. What shall we try? 2, maybe? 1, 2, 6, 12, 9, 18, hot dog. So I know x equal to 2 is a solution. I am left with, this is a cubic, so I'm left with x squared plus 6x plus 9 is 0. Can you find factors of 9 that add to 6? It's an easy one. No number in front of the x squared. Sure, 3 and 3. So this would be x plus 3 times x plus 3, which gives me negative 3 twice, which means it bounces. Okay? So I have hits at 2, negative 3 twice, it bounces. The y-intercept is going to be way down here at negative 18. Okay? End behavior in a cubic is down on the left, up on the right. Yep. So this is going to come up to negative 3, and because it was used twice, it's going to bounce. So it's going to come up like this, bounce, come down to here, then up through here, okay? And goes through 2 because 2 is only used once, right? All right, I hope you're getting onto this. I hope I'm not boring you. If I am, you can go to the end and start your homework. Let's do the last one. This one has a missing term. 1, 0, negative 2, and 1. This is going to be easy for possible zeros. It's plus or minus 1 over plus or minus 1. It's plus or minus 1. That's all you got to choose from. So I'll try 1, 1, 1, 1, 1, negative 1, negative 1, work. So x equal to 1 is a 0. X minus 1 is a factor. This knocks it down 1. So this is 1x squared plus 1x minus 1 is 0. Can you find factors of 1 that subtract to give you 1? No, you can't. 1 and 1 do not subtract to give you 1. You're going to have to use a quadratic formula opposite of b. Negative 1 plus or minus square root of b squared minus 4 times a times c all over twice a, which is just 2. This becomes 5. 1 plus 4 is 5. Square root of 5 is, helps to turn the machine on. Square root of 5 is 2.24. 2.24. So I want negative 1 plus 2.24 is 1.24 divided by 2 is 0.62. Okay? 1.24 divided by, yep, perfect. Negative 1 minus negative 1 plus that is negative, is positive 1.24. Yeah, so negative 1 minus 2.24 is 3.24, and 3.24 divided by 2 is 1.62. Okay? Can you all see? Am I writing big enough? Hopefully. Well, that's getting a little iffy, so I better be careful. All right, so let's sketch it. So I have no zeros repeated, and everything is positive here. So I have 1, I have a 0.62, and I have a 1.62, okay? It's the y-axis at 1, okay? And the end behavior on a cubic is, that's interesting. Something looks a little odd there. Let me double check. It seems like okay, sorry. I realized I have slight error here. When I did the second one, -1 minus 2.24 was a -3.24, so that should be -1.62. Sorry about that. So the -1.62 is down here, and behavior in a cubic, down on the left, up on the right, so it comes up through, it's here at 1, down through, and back up. Notice once again, there is no bouncing because none of the zeros were used an even number of times. All right, so homework is there. There is a parabola once again, put in standard form, sketch, find increasing, decreasing, and so on, and then problems on page 260. Enjoy, enjoy.